Okay, the next question is the question number 12. So the question is the stainless tube of thermal conductivity Ks is given of 2 cm inner diameter and 5 cm outer diameter is insulated with a 3 cm thickness of asbestos. So asbestos thermal conductivity is given. So if the temperature difference between the innermost and outermost surface is given as 600 degrees Celsius. So here to find out the heat transfer rate per unit length. Here to find out watt per meter. Okay, unit length. So the solution here, so it is given, it is a stainless steel tube, this one is steel tube which is covered by inner diameter of 2 cm, 5 cm outer diameter insulation is here, and 3 cm with the thickness of asbestos. So the 3 thermal conductivities are given. This is a cylindrical tube. So we know the formula of cylinder of Q, heat transfer rate is Q is equal to delta T divided by R. So here the delta T is Ti minus T naught, inner minus outer temperature, to 2 pi Ks. They will ask as Q by L. So that this is a formula to find out. So the question is given, delta T is given in the question. So here what are the data is given. So as per the question is diameter D1, D2, thickness is given, temperature is given. So here and find out Ks is given, thermal conductivity of S steel, and D1 is given, you have to find out our radius, and D2 is given, you have to find out the radius R2. Then thickness is given, so you have to find out the thickness with the help of thickness. You have to find out the radius 3, R3 is equal to R2. So what is the thickness? R3 is equal to R2 plus thickness. So you will get the R3. So you will get the value of R1, R2 and R3. So we need as here R1 and R2 and R3 and R2. Then you know the Ks and Ks, that is also given in the question. So K is given in question, K is question is given. So that you have to substitute it, so you will get the answer. These are the values given in the question. So you have to convert all in meters. Okay, so 600 degree is given, so you have to convert it delta T by R. So you will get the answer of 9.72 or 9.44 watt per meter. As per your answer, here it is approximately the answer is B. 9.44 is your answer. So approximately the answer is given in the question. So that comes to the next question. So comes to the next question as so the next question is question number 13. So asked in 2005 as 1 mark. So just you have to be listen here. A well machined steel plate of thickness L is kept such that the wall temperature are Th and Tc is given. So this one is the diagram. Th and Tc is given, and the seen in the figure, say a smooth copper plate of same thickness L. So length L is now attached. So another copper plate is attached with without gap. Yes. So without gap, it is indicated in the where below. Temperature, the interface is Ta. So the interface temperature, so outer surface temperature Th and the interface temperature Tc. So interface temperature between the copper and steel, it is Ta. Outer wall steel, and the temperature after attaching this copper to steel, the temperature of the outer walls is still the same as Th and Tc. This is the same as Th and Tc per unit area Q by A. 2 cases in the direction shown in the way. Which of the following statement is correct? So you have to be find out the statements given. So you have to be find out the statements. So you will comes to this one. So first you take the first case as steel. This is the first case. This is the second case. So you take the first case. So what is the steel? So we know the formula. This is a outer temperature. This is inner temperature. In the outer temperature, this is thermal conductivity. So in the first case, Q is equal to delta T by R. So delta T is nothing but inner temperature minus outer temperature divided by R1. Here the R is equal to L by Ka. Okay. So that is the first R1 resistance, and the second is, this is the second case. So we know the formula Q is equal to delta T by R. So here the two things are there. So it is acted in series. So that is R2 plus R3. So we know the formula R2 is equal to L by Ka. and R3 also is L by Ka. So here K is a copper and is K for R2 is steel. So we know the formula. This one is, so we have to compare this first and second case. So this is the second case and this is the first case. So definitely R1 plus R2, sorry, R2 plus R3 is greater than R1. So we know the this one is the first thing. So definitely it is a positive value. So R1. So you have to add that, you will get the positive value. So that R1 plus R2 definitely it will be a positive value. So that, so if, so we know the formula Q is equal to K into dt by dx as per Fourier law of heat conduction. So you have to compare this with the resistance. So K and resistance. So Q is equal to K into dt by dx. So in this equation, so we know the formula Q by A. So if the resistance is higher, heat will be lower and vice versa. Okay, so in this we take this one, Q is equal to delta T by R. Okay, so Q is directly proportional to 1 by R. If R is very higher, Q is lower. If R is lower, Q should be higher. So in this case, R2 plus R3 should be higher and R1 is lower. So R2 plus R3 is higher means definitely Q will be lower. That is, Q will be a lower value and Q1 will be a higher value. So the first, we take this as this, we take the Q1 greater than. So we take this 2. These two are the answer. And comes to the second part, we have to find out this thing. Okay, so first thing is definitely Q by, so the directly we write Q is equal to delta T by R. And here second case Q is, this is R1, this is R1, this is R1 and R2. So delta T divided by R1 plus R2. Definitely R1 plus R2 should be greater. So this is Q1, this is Q2. So that's why Q1 greater than Q2. So comes to the second thing. So this is the second thing. So we know the R2 always greater than R3. Why? Because we know the thermal conductivity of copper and steel. So which one is greater? Copper is greater. So that definitely R2 greater than R3. So that we know the formula Q2 is equal to delta T by R. So similarly, so we will get the R2. So like Q2 is equal to delta T by R3. So we will get the value. So from this case 2 diagram. So that we know the formula R2 is greater than R3. So we have to apply this R2 greater than R3. Instead of R2, you have to write Th minus A divided by Q2 and Ti minus Tc divided by Q2. Since Q is equal, so you have to be cancel each other. So you have to write this equation, Th minus Ti greater than Ti minus Tc. So we have to be take this as in the right and left hand side. So Th plus Tc is equal to 2i. So I will find out that Ti is equal to Th minus Tc divided by 2. So the answer is, this question is Th greater than Tc. The answer is D. Okay, so answer is D. So comes to the next question. Question number 14. So in case of one-dimensional heat conduction in a medium, one-dimensional heat conduction in a medium with a constant properties, T is the temperature and a position with the X at a time T. So then dt by dt is proportional to. So this is a question we should be remember some equation that is one dimensional. What is one dimensional heat equation? That you should remember. So this is a one dimensional heat equation. This is the three things. X is there, Y is there, Z is there. So we take one dimensional heat equation means we take only the X coordinates. So dou square T by dou X square is equal to on the right hand side rho density into specific heat constant pressure divided by thermal conductivity into dou T by dou T. So here, so we take this constants out. So we'll get what is the question here is you have to find out dou T by dou T is proportional to dou T by dou T is proportional to dou T. This one is proportional to dou square T by dou X square. So the answer is D. So the answer is D. Okay. So comes to the next question. So frequently asked in the lot of competitive examination. So just question number 15. So the heat flow through a composite slab as shown in the figure. Okay, so its diagram is already given. The depth of the slab is 1 meter. So here the depth is given as 1 meter. The K values are in watts per meter Kelvin. The overall resistance in kilowatt. So the K value K is given in the diagram. Then length is given as 0.5, 0.25. So this one is acting. So you have to find out the value of heat flow through a composite slab. You have to find out the heat flow through a composite valve in kilowatt. Overall thermal resistance in kilowatt. Have to be find out. So the question here. So you have to be remember this diagram. So question is given as a diagram. So we take this as length to L1. This L2 is equal to L3. So here K1, K2, K3 is given. So this is the resistance diagram. You have to find out the resistance diagram. You know the resistance as here the total resistance in this diagram as per the question is RT, total thermal resistance is equal to this one is R1, that is this one is R1 plus you have to arrange it in a parallel, so that is R2 R3 divided by R2 plus R3. So here the R1, where R1 you know the formula. What is the formula R1? L by Ka. Then R2 is equal to L2 by K2A2, L3 by K3A3. So here will be all the values given in the question. So what is L1? Here this is L1 and it's given in the question as 0.5. That is 0.5, 0.25 is given in the question. So you have to substitute it. Then A1, A2, A3 are given in the question as per the question. So here it is, you have to find out the L value. Area length into this breadth, length into this breadth. I take the area A1, A2, A3. Similarly, K1, K2, K3 is given in the question. So that you substitute it, you will get the direct answer. So this is very important. Overall thermal resistance is given. Some of the questions they are asking the Q is heat flow rate is given. So Q by you have to find out the Q. So in this question they are asking the thermal resistance. So you have to get the answer of 28 point approximately 28.6. The answer of 28.6, that is answer C is your answer. Okay, so this is very very important. So you should be remember this type of questions. So the next question. So the next question already is in a composite slab. So it's another important question. A lot of time it is asked in the university as well as this GATE examinations. Okay, in a composite slab, this one is a slab. The temperature at the interface, this one is a temperature at the interface. Okay, temperature of interface between the two materials is equal to the average temperature at the two ends. So this T1 plus T2 divided by 2 is equal to T interface. That is given in the question. Assuming steady one-dimensional heat conduction, one-dimensional steady. So 4 equations are there. You remember steady, unsteady, with a sphere, with a cylinder, etc. So just assuming steady one-dimensional heat conduction, which of the following statement is about the respective thermal conductivities? So we know the first steady state heat transfer through composite slab. Okay, heat transfer through slab 1 equal to heat transfer through slab 2. So you should remember the equation, this one, as for a steady state heat transfer through a composite wall, heat transfer through a slab 1 equal to slab. So we know the formula of heat transfer through a conduction, K1 into, so it is given in the question. This is 2B, this is B. So length is given. So as per Fourier law of heat conduction, Q is equal to Ka into dt by dx. So we have to equate this one as first slab and second slab. So that you will get the B and B is cancel each other. So that is K1 into A and A is cancel each other. So the final K1 into T1 minus interface is equal to 2K2 into T interface minus T2. So that you will get the answer. T interface already given in the question. T interface is equal to T1 plus T2 divided by 2. So that you have to substitute this interface here. You have to substitute these values. So you will get the multiple of that. So you will get the answer like this. So the final it will be cancel each other. So it will be K1 is equal to 2K2. So the answer is, this is K1 is equal to 2K2. So the answer is D. So comes to the next question. So question number 17. So with an increase in the thickness of insulation. So take the one copper wire or steel, etc. Increase the thickness of insulation around a circular pipe. You take one pipe, you have to increase the circular pipe, increase the thickness of circular pipe, heat loss to the surrounding due to. So after insulation, heat loss to the surrounding. What is the reason behind that? So in this we should remember this thing, that is Q. If it is increases sometime, it will be increased. Heat is increases somewhat heat is increases somewhat up to critical radius. After that it will be decreases. So that you should remember. So as per you note, this note also it should be remembered, as insulation is added to the circular pipe. Okay, the outer surface temperature will be decrease, become higher thermal resistance. So if you have a coating is in the circular pipe, the outer temperature decreases as a higher thermal resistance. But at the same time, surface area for the convective heat dissipation will increase, causing more heat loss. So that those two oppositions. So we will be question as this convection increases, it's good, and while that due to conduction decreases. That is the that thing. And so this is the, I think this answer. Convection decreases, no, and then convection and conduction decreases, it is not the answer. Convection and convection increases, it is not. So the answer is this one, since it is outer surface. So the reason is outer surface circular pipe, the temperature will decrease and resistance will be increased. So that's the answer. Answer is A. So also you remember that this thing also, maximum heat transfer heat loss surrounding the critical radius of insulation. Already we know the RC, the critical radius of insulation, and also it is known as also critical thickness of insulation, inner surface of a radius of cylinder. We know the critical radius of insulation. So comes to the next question. So what is the question means? Here a long glass cylinder of inner diameter 0.03 meter. So inner diameter is given and outer diameter is given. Okay, a glass cylinder carries a hot fluid inside. So it will be carry a hot fluid with the outer surface as well as the inner surface. Its diameter is given. Thermal conductivity of glass is given. So you have to find out the thermal resistance. You have to find out the value of thermal resistance per unit length. And we find out. Okay, so we know the formula. Glass tube, hollow tube is there. So find out in this type of questions, here we find out radius R1, inner surface R1 and outer surface R2 from the diameters. Then K is given. So we know the formula of thermal resistance of a cylinder, long cylinder. This is a formula to find out the thermal resistance of a cylinder. So 1 by 2 pi K into L into log R2 by R1. This is a formula to find out the. So all the values are known value. K is given, R2 is given, R1 is given, and it will be find out. So L is not given, so it will take per unit length. We take it as 1 meter. So I will get the answer is 0.077. So this is the answer. So comes to the next question. Comes to the question number 90. So in this question, heat is being transferred conductively from a cylindrical nuclear reactor fuel rod of 50 mm diameter to water at 75 degree temperature is given under steady state conditions. Okay, it is given as steady state condition. The rate of heat generation within the fuel element is, so rate of heat generation is also given 10 power 6 watt per meter cube. And the convective heat transfer coefficient is 1 kilowatt per meter square Kelvin. Convective heat transfer coefficient. Outer surface temperature of fuel element. So in this type of question, heat is being transferred for conductively. After that, this one is nuclear reactor. So in this type of question, you have to be apply energy balance equation. So what is energy balance equation is nothing but rate of heat generation is equal to rate of convective heat transfer. You should remember, rate of heat generation is equal to rate of convective. So what is given in the question? Heat is being transferred conductively for a cylindrical nuclear reactor. So steady state condition. So heat generation, the word is generation. So rate of heat generation is given in the fuel element 10 power 6 per meter cube. So rate of heat generation is equal to heat generation into volume of fuel rod. So this is a per meter cube, and is equal to heat transfer, convective heat transfer, that is Q is equal to HA delta T. So that from this equation QG into fuel rod is there, so pi by 4 d square into L, that is the volume of that cube, and H naught, that is the heat transfer coefficient, and pi dl, that is area of this cylinder, pi dl into Ts minus T naught. So Ts and T naught is given. So in this you have to substitute it, so I will get this answer. So cancel each other, this pi and pi d, and 1d is cancel, L and L is cancel each other. So finally we will get this one. So we have to substitute this diameter is given, QG is given, 4 is given, Ts minus T 75. So T 75 degree is given. So I have to find out the value of Ts. So we will get the value of Ts as 360 Kelvin. That is the outer surface temperature of the fuel element would be 360 Kelvin. So the answer is 360 Kelvin. So the answer is 360 Kelvin. So in this type of questions you should remember, if the heat generation is given with conductively, so you have to apply the energy equation. That is very important. You have to apply the energy equation. This one you remember is this type of questions. Here rate of heat generation is equal to rate of convective heat transfer. So that comes to the next question. So the linked questions, two questions are there. So consider steady one-dimensional heat flow in a plate of 20 mm thickness with a uniform heat generation of 80 megawatt per meter cube. Okay, the left and right phases are kept constant as 160 temperature. Both the temperatures are given. The plate has a constant thermal conductivity, K is given. So the location of maximum temperature within the plate from the left face. So it is here to find out the location of maximum temperature within the plate from its left face. So this is, so again what are the given data? We just get, consider a steady one-dimensional heat flow in a plate with 20 mm thickness. So this is a 20 mm thickness. We have to convert it into meter. Then heat generation, uniform heat generation is given 80 megawatt per meter cube. So megawatt into converted into 10 power 6 watt per meter cube. Then the temperatures are given 0 to maximum length, T0 to T16 to 20, and K is given. So that from the equation, one-dimensional steady flow energy equation, we know the formula. What is the formula for one-dimensional steady flow energy equation? This is the formula to find out the one-dimensional steady flow. One-dimensional, that means only x direction. Dou square by dou t, dou x square into qg by k is equal to 0. So you have to find out the value of, what is the value that we find out? It's a thermal conductivity. So you have to find out the location of maximum temperature. Location, you have to find out the location for maximum temperature. Which distance you have to find out from its left side. Okay, so that you have to write the one-dimensional heat equation. So that you have to substitute qg and k. So you will get the dou square by dou t in this equation, plus dou square by t by dou x square plus 400 into del cube is equal to 0. So in the integrating, so you have to find out the temperature value. So this is a two in differentiation. So this is the first, we have to integrate one time and integrate in second time. So we will get the answer of this one. So from that you have to find out the C1 and C2 value. Okay, so this is the equation. From that you have to find out C1 and C2. So how will you find out the C1 and C2 from the boundary conditions? So boundary condition is given. First one is 0 and second one is, first is 0 degree, 0, x equal to 0, temperature is equal to 60. You have to apply it. So you will get the value of C2. Similarly, second is x is equal to total larger length, that is 0.2 meter, and temperature is 120 degree. We apply the equation. So you will get the C2, here C2 value you have to substitute it. So you will get the value of C1. So substituting the C1 and C2 value in the previous equation, C1 previous equation means this one. So you have to substitute the equation number 1. So you will get the value of thermal conductivity. So you will get the equation like this. Then we know all the thing, that is condition for the maximum temperature. Condition for maximum temperature, dou t by dou x is equal to 0. Okay, so dou t by dou x is equal to 0 means you have to again dou t by dou x, this one is you have to again this one is take it, and x is equal to 0.5 or not. So you will get the answer, dou t by dou x is equal to 0. So you will get the value of x is equal to 5 mm. Similarly, so this is the answer for the question. So this is the answer. Answer is C. So comes to the next question. Same question. So what is the value of maximum temperature? What is the value of maximum temperature within the plate? It is what is the temperature? Maximum temperature means you have to find out the x is equal to 0.05 meter in the T max equation, T equation. So we will get the substitute these x values here. What is the value, maximum value? So we will get the temperature of 165 degrees. So answer is B.